The Nuclear Talent Show is a long-format interview podcast hosted by my husband and nuclear engineer, Russell Goff, produced by our staffing company, Nuclear Talent Scout. For more educational and career-boosting content, including exclusive lessons from our talent show guests not included in the show, visit our website, nucleartalentboost.com. You will get access to all of our content, our forum discussion spaces, and membership in an elite talent pool that will shoot you to the front of interview lines. All this and more for free in exchange for your resume and job preferences, which allows us to save you time because we'll only reach out to you about states, rates, and dates that fit your desires, unlike so many other recruiters. We can place you directly in-house with our clients or as a staff aug contractor. You sharing this video with your colleagues could help them obtain life-changing jobs, and it allows us to continue making this amazing content for free. So please like, share, and subscribe to our podcasts, follow us on LinkedIn, and enjoy the show.
I'm excited to welcome my next guest, Adam Deatherage, who is with the Analysis and Measurement Services Corporation, a little outfit that specializes in I&C and like 20 other things that we'll talk about. And, you know, it's sort of a matter of Nuclear Talent Scout specializes in helping people with hidden talents be recognized. And certainly AMS, even if people have heard of them before, most people just aren't aware of everything that you guys do. And so we're going to showcase some of your arsenal of I&C and other related services, in addition to speaking about how does a person even become an I&C engineer. So any listeners who are coming out of college or in a different department at a nuke station that want to become an I&C engineer because they're just very in demand and the pay is high and the problems are real there. So help getting people into the I&C field. In addition to, you know, another topic we'll cover today is just next gen nuclear I&C problems and opportunities. What are some of these microreactor and advanced reactor companies facing compared to a traditional light water reactor with respect to all the different I&C problems and costs that need to be solved. So yeah, welcome to the show, Adam.
Yeah, thanks, Russell. Appreciate you having me on and really looking forward to today's discussion. I know we got a lot to talk about.
AMS offers different EMC courses and services and things like this. And I think that it's sort of a to-do that we're semi-punting on to another guest, Chad from your team. Chad will come in later to offer a lesson on nucleartalentboost.com. AMS offers like a 3-day paid course where you're like actually touching all the EMC related instruments this year down in Florida in the winter.
That's right. Chad loves to go to Florida in February and spend some time down there. So looking at coming up here should be on our website and already.
Nice. Yeah, like the I&C issues that new reactors face, like you go to new reactor vendors and operating plants all the time to do like troubleshooting and field service work and provide various different I&C services. So like what are the sore spots that you're seeing in your customers right now?
So as a background on AMS, there's kind of three main areas of work that we do within the existing fleet that it really is kind of channeling to similar problems in the next generation of nuclear power plants. So cable testing, cable condition monitoring, cable aging management is one of those. EMC you already touched on, which is electromagnetic compatibility. And then kind of the other third is our core services. So that's really when you start talking about your I&C systems, your temperature, pressure, level, flow, neutron flux, your rod control systems, nuclear instrumentation, those types of things, kind of the catch-all term that we jump into. And so when we talk about the next generation of nuclear power plants, a lot of AMS's focus to this point has really been on getting ahead of some of these I&C issues that has given the existing fleet challenges for the last 50 years of operation, and making sure we solve those kinds of problems on the front end. So trying to look at things, whether it's with EMC issues on the design side of your control system, how you're going to have a different operating environment than what's been historically used in the existing fleet, or with cable related issues. You have plants that are at higher temperatures or they're much smaller, so you're not going to have much room to route cables, or they're going to be routed in much harsher environments, and you may need different types of insulation materials or different types of just different techniques that you can be able to use to monitor those cables long term. So those are just a few examples that we can go into a little more detail on, but those are the types of things that we're trying to help the next generation of reactor development.
Nice. I think that one of those issues that you just touched on, which I think we'll talk more in depth on with Chad on this, but the elephant in the room for all nuclear new builds is that everyone does their EMC testing to Reg Guide 1180 levels. And, that's what like their design specifications say. But Regulatory Guide 1180 is essentially based on historical average levels at light water reactors for like electromagnetic fields that would be like present typically there. And so people will just follow Reg Guide 1180 and we're done. But, it's not really like that straightforward because the new plant's levels might be higher than past historical levels. And, there's needs to be a little bit of common sense in terms of making sure that you're not just making your cable lick some giant motor in its routing or something like that. But with all these really tight confined spaces in some of these microreactor designs, it can definitely be very challenging. So
no, that's a really good point, Russell, because there's actually an ongoing effort now through the Electric Power Research Institute to try to get a re-baseline of all of the light water reactors, because, again, like you mentioned, the initial plant composite levels that are in like the Reg Guide and the EPRI TR 102323 guidance, those are all from 20, 30 years ago. And so there's an ongoing effort from EPRI right now to re-baseline and get new information that's just for the existing fleet of how things have changed in the last 25 years with wireless implementation, with plants, all kinds of new variable frequency drives and other things that it can be pretty aggressive noise sources in the plant, and other things that maybe are less susceptible. And so those are types of things that are ongoing just in the existing fleet. And then you have a new generation of nuclear power plants that haven't been built yet. We don't really know exactly what the electromagnetic environment is going to be and what the control systems will look like. And there may be some things about them that make it maybe a little less harsh from an EMC perspective, just because it's not, especially for some of the smaller reactors, you don't have as large of components, but the confines may be much less, and you're trying to really maximize what you can do in a relatively small amount of area. And so it's definitely going to be something that needs to be addressed and will be hard on the front end you're not going to be able to get a plant composite of any of these plants until they're built. And that kind of leads to the beginning with the end in mind idea of, okay, we need to, on the front end, know EMC is going to be something that the NRC is going to ask questions about, that we're going to have to address. And do we want to commit ourselves to things like the Reg Guide just because that's what's out there? Or do we want to have a more plant-specific approach where we can look at it from what's a reasonable thing, so we maybe aren't using overkill and going way beyond what is really needed, and to a point where most of the systems just won't be able to pass on the front end, but also going in with a mindset of, we do want to make sure that our equipment are able to withstand the environment that they're going to be put in, and they're not going to cause any harm to any safety related equipment that could be nearby. Mm-hmm. That's really the two kind of, when you think about EMC at a high level, those are your two concerns. What you're putting in is not going to impact any safety related or important to power production type of equipment nearby. And then on the converse, you're not putting in any safety related equipment that's going to be susceptible to something that could cause a unexpected actuation.
Yeah, no, 100%, because I think that there's like this progression of expertise in acquiring any body of knowledge, but I think especially in EMC, I think that there's a large gap between where most even digital I&C engineers need to be and like where their current knowledge state is. And then like, if you're completely not in the game at all, then like you're just off the map in terms of where you need to be. And certainly that lesson that Chad's going to be developing here with us is definitely meant to help amend that for everyone, because my 7-year-old daughter, right, she's progressed from thinking that lights turn on because of magic. And then, she realizes now that there's this thing called electricity and somehow it's involved in making the light go off. But like she still doesn't like really know that much about electricity. And maybe by the time she owns her own house, she'll have learned what an amp is maybe, and like, be able to speak to like whether 50 kilowatt hours is a lot or a little electricity, and whether 10 amps is a lot or a little, like in a relationship to a cell phone or a house panel. There's definitely people presently have maybe gotten to the point where they realize like EMC can be an issue. It can make my equipment do things that I don't want it to at times that I don't want it to. Very few people could say into it like whether 30 dB microvolts at 20 megahertz a meter away is like a huge or barely any
That's right.
of an emission. once you get there, you can actually reasonably interpret standards and test results and just your general path forward on designs.
Yeah, that's right. When you start talking in log scales, people just their eyes glaze over, and that's even in the existing fleet. One of the challenges that we've seen is oftentimes EMC is kind of treated as black magic. They know it's a problem, and sometimes can even be a scapegoat of, we had an issue that was kind of spurious and never happened again, so it was probably an EMI issue. And so I think that knowing that this is a science that can be addressed on the front end. There are EMC best practices that should be followed, but that is one of the challenges for the next generation of reactors. Even when you talk more broadly about I&C, whether it's the EMC piece of it or just more broadly with sensors and your control system architecture and those types of things, is it does tend to kind of take a back seat to some of your other aspects of the reactor design, like your fuel, where you're going to get your fuel, how are you going to lay out your core, your power conversion. Those are the things that are really kind of hot button, top of mind issues. And we can measure temperature. That's easy. Or we can figure out how to measure flow and get a power measurement. Like, that's the easy science. And the reality is maybe, but maybe not, depending on the temperatures you're measuring and the medium that you have, flow measurement, and some of these gas reactors is going to be a challenge. M dot delta T, that's how you measure power. And that's power is what makes money. And if you've got a wide uncertainty band on how you're measuring your power, that's real money that it could be costing you just because you don't actually know what you're outputting. Or sometimes just even it's a little bit of a backseat. It's something that you think, oh, we can figure this out. And sometimes you can. And sometimes there's going to be at least a little bit of development effort needed on the front end. And you don't want to get in a situation where you're about ready to start up the plant and having these kind of I&C related issues.
Yeah, but that almost always happens, right? Like whether it be Vogel or Alcaluto or any of these like years delayed projects, it's like usually a series of like, oh crap, there was an I&C issue, take 4 to 5 months to resolve, and then everyone's sitting there, and then like another one pops up, and then the 5-month clock starts again. And
that's right. These are the challenge. I mean, there's things with like the nuclear grade concrete, and there are other like larger, huge delays type things that happened with Vogel, but some of it was cable related problems and things that are really like, they're not that complicated. It's just, it has to be done right the first time, and it has to be the more thinking on the front end and planning you can do to make sure you address those, and you don't end up in that kind of reactive mindset versus a more proactive getting ahead of it on the front end. It's critical when you kind of get from the, hey, we've been designing this thing forever and now we actually need to go build it. How we build it and how we lay these things out and how we instrument it really do matter.
Yeah, it really sucks to be drilling holes for extra cable runs through nuclear safety related concrete, but we've all been there. And whoever keeps putting way too few penetrations in all these walls, like, we need to find their names and make them pay. But anyway.
No, and that's going to be a legitimate challenge for a lot of these, especially microreactor developers. We talked about it a little bit the last time we spoke, but these developers that are going to have smaller footprints, smaller control rooms, you're still going to need at least 3, hopefully 4 channels of redundant I&C for your protection system. And all those sensors, all those systems are going to have cables associated with them, and those all have to go somewhere. Routing cables is going to be a challenge just from a footprint perspective. So those are, again, little things that are necessarily top of mind, but will make a difference.
Yeah, piggybacking off of that cable stuff, I think one thing that people often overlook is that traditional nuclear cabling, like safety related nuclear cabling, is like just very fat and thick typically. It's just made to like be sitting in like a boric acid bath for like hours at a time and other things like this, in addition to being like ridiculously flame proof, way over ridiculously flame proof. And so oftentimes like designers are surprised to like learn that the cable is like this thick, even though like
it's here, not here.
Yeah, even though like the actual metal conduit inside is like tiny, it's got this fat insulation around it. That's one of those things where, in talking about finding new cabling that's thinner, you just sort of have to like know your design basis of your plant. There was the design basis LOCA, and that's why the cables are so fat in traditional light water reactors. And like, yeah, fire was a big deal in a traditional plant, the Browns Ferry event and all that. But like,
shut them down for a long time.
Yeah. Yeah, but like, separation wasn't even like a thing back in the day, right? Divisions and
Yeah.
routing all your cables different places. Now it is. And like also a lot of these passive plants, it's like you can be thinking about whether you really need that much fire protection or not.
That's the question that is really kind of the crux of the advanced reactor problem is, can you take a different approach than what you've done for the existing fleet? Because if you have to do all of the same design requirements and EQ profiles and all of this that's been required by the existing fleet from broadly, because of the challenges with your lack of passive safety features and those types of things, then you're designing a smaller reactor in a lot of instances, and you have the same amount of safety features and the same amount of built-in redundancy and built-in conservatism, and you're making less power. And so it's going to be hard to be economical. But so you really, you kind of have to shift your mindset and take a different approach that may be a little bit outside of what's just historically been done to take advantage of the great designs that we have. None of the designs that you look at are just like bad. None of them are just, oh, this will just never work. They all like technically are feasible, and I think all have a pretty good shot at making it with the right investment. But if you try to do things the way we've always done, we're going to keep getting the same results. And combining that, we got to have enough regulatory certainty that they're going to license the thing, but we need to do it in a way that's cost effective.
Yeah, I would argue that like 10 CFR 50 itself is just the embodiment and encapsulation of half a century worth of like experience with light water reactors. It sort of like teaches you how do you build a light water reactor, and it's great. But like if you don't want to build a light water reactor, you sort of are shooting yourself in the foot to like perpetually do everything that was in the precedents. But yeah, I think that you touched on something in terms of like cost control, because you can look at I&C and there are some like specialty fission chambers and stuff that for like a safety related division of it ends up running like hundreds of thousands of dollars and all this.
Sensors are very expensive.
Yeah. And when you have a gigawatt of power to be like distributing that cost over, then it's like not a big deal. And therefore, like I&C gets overlooked. But like now, when you've got a 5 megawatt electric plant, and you're trying to throw 4 channels of fission chambers on it and like all these other fancy sensors, and then you'd have like an 8 or a 12 unit plant or whatever, and so you've got times 12 of that I&C. I&C is becoming like a much larger than previous cost for a lot of these advanced and micro reactor companies, and so it's certainly a matter of, hey, sharpening the pencil to drive I&C costs down is sort of semi-necessary. It's sort of why it's great to specialize in I&C nowadays, I
That's
guess.
right. No, and I think, I mean, it's going to be a combination of, okay, we talk about the passive safety features and things. What doesn't actually need to be traditionally like safety related? What can be a commercial grade type item so that it doesn't have all of the pedigree and testing that is really what drives up the cost for a lot of these items. And then especially for the first few reactors, the demonstration reactors, generally you want to over instrument those. You want to get as much information as possible, have a little bit of excess in how you instrument those first. But after that, once you have a good understanding of how these things operate and the long-term pedigree, then you can start to really understand, okay, what do we maybe not need in some of these iterative approach in a lot of these designs. We talk about scaling and modular. For the nth of a kind design, how can we reduce some of these costs while also maintaining, like, in some instances, it's really useful to have 4 channels. Some of the existing fleet, the plants that only have 3 redundant channels, makes maintenance difficult. So take out one, put 1 channel into test, and then you're down to a 1 out of 2 logic. And if a spurious trip happens or something, then you trip the plant. And so having a 4th channel, you can take that in test. Then you're still in a 2 out of 3 logic, and it reduces your plant risk. So that's a ongoing reliability thing that could, again, anytime you don't want to be worrying about risk and plant trips when you're from a spurious EMI signal that's because a nuclear instrument had a little bit too much noise on it. There's always trade-offs, that you're always trying to maximize what can I get the most bang for my buck and optimize that value for what you're paying for. And so that's really the things that you want to be thinking for, but you got to do that now. You can't wait till you're, hey, we've got this design finalized and now we had a temperature sensor for this, and okay, I need a temperature sensor. It's like, okay, well, thermocouple. What type of thermocouple do you need? RTD? Is it going to be installed in a thermal well? What are the response time requirements? How accurate does it need to be?
Yeah.
All of these things that you need to think about that oftentimes it's just, I just have a temperature sensor that measures temperature right there.
Yeah, it's always fun to have all of your like ASME Section 3 pressure vessel stuff done, and then to just be like, oh, way late in the game, hey, could you just like throw a thermal well in there? Just throw it in, like no big deal,
No
like
problem.
so we can get a temperature measurement. Yeah, I think that one thing that I really like about what AMS in particular brings to the table and specializes in is just how to do calibrations and maintenance, essentially, especially again, the microreactors and advanced reactors. They've got a lot higher radiation fields in certain spots, which we've got a separate lesson in our library about how to do radiation hardening on electronics and stuff, which people can go check out. But even more so than that, how are you going to like get in and calibrate instruments, and can you do it while they're just sitting there in place, and can you delay having to do that maintenance and all these sorts of things? It's like AMS just literally wrote the book on so many of these techniques. And I think that I've been at several different companies where AMS was essentially a consultant to us, and you guys would just come in and point out 5 different problems and also like at least 4 of the solutions to the 5 problems. The 5th one, they'd be like, yeah, you just got to change your design, man. It's bonkers. But could you speak to some of the techniques that you guys offer and have pioneered just for people's awareness?
Yeah, for sure. So yeah, automating I&C maintenance activities is really like the main core competency. The founding technology of the company was automating temperature sensor response time testing. That was as a very kind of niche example, but we've kind of built off of that over the years to really any type of I&C sensor or problem or maintenance related issue. We really want to come in and help improve that process, streamline it. Probably the biggest example that we're working on the existing fleet that has a lot of, I think, potential in the next generation of reactors as well is a technology we recently had approved by the NRC called it's online calibration monitoring of pressure transmitters. So pressure level flow. Most of typical PWR in the U.S. has about 100 safety-related pressure level flow differential pressure type measurements. And historically, plants have gone in and calibrated all of those transmitters every outage. And it's a lot of work. And so it's, again, one of those things that you wouldn't really think about. It's like, oh, calibrating transmitters, like easy, right? Just go check it, making sure it's right, put a ramp signal through it and make sure that you hit all the different pressures and you're good. But it's a lot of work. And so that's a thing that we've been working on for a number of years, and we're deploying throughout the fleet now. But there's tons of cost savings just from not having to calibrate pressure transmitters. Instead of manually calibrating them using plant computer data to automate the process, you only go calibrate what actually needs to be calibrated. And that's the piece of technology, online monitoring in general. I think especially microreactors and some of these smaller designs are really going to have to jump on. Because if they don't, there's just, again, you have smaller reactors, less power output, and a lot of maintenance that has to go on. If you can automate that, you can streamline those activities, whether it's calibrating transmitters or temperature sensors or more advanced online monitoring techniques for like identifying process anomalies, or even like things like measuring flow can be done with different temperature sensors, cross correlation techniques to be able to get more of a better understanding of what's going on in the reactor. There's a lot of opportunity in the online monitoring space to really get a lot more value even than what we're doing in the existing fleet.
No, that's very good. And those instruments that you can't even reach if you wanted
Right.
to, right? Can I just leave them there forever? Just cross calibrate them based on nearby sensors and
Yeah, identifying those kind of problems ahead of time and being able to do everything remotely, because that's one thing the existing fleet has learned pretty well, is that oftentimes if you go and touch it, you're more likely to break it than if you just leave it alone. And,
yeah.
and so that's when things are working properly, let them keep working properly. These types of online tools where you can use data that oftentimes it's already going to a Pi historian or it's already going to the plant computer. So you have access to a lot of these data, and maybe you need to tweak things a little bit. Like you need to sample faster instead of once every second or once every 5 seconds. But that's where we have like data storage now is much different than it was 45 years ago.
Yeah.
And so you can really take advantage of a lot of these technologies and techniques that just weren't really feasible or economical.
Yeah. I loved what you said about like half the time you go out into the field and like think that you're doing this proactive preventative maintenance, and then you just end up breaking it. And I think I ate a fortune cookie once that said something like, it is often in trying to prevent our fate that we seal our fate, or something like that. And I was just like, yeah, man, that's true.
Some good old wisdom there.
Yeah, that's right. I was mentioning that you guys basically like wrote the book. If you're looking to get into I&C engineering, or if you're just trying to get out of a bind that you found yourself in, I've got the first edition of the
Maintenance of process instrumentation and control systems in nuclear power plants.
That's right.
Sensor performance and reliability is another good one. Dr. Hashemian is a prolific author. We were talking the other day. He's got something like 400 different journal articles and academic papers. I mean, that's the AMS actually came out of a joint research project between the University of Tennessee and Oak Ridge National Lab, and it's 1977. This is way back. I think that's kind of always been part of a core of his passion, wanting to make sure you mentioned just the resource it's been to you, and just making sure that a lot of this information is not just stuck in our heads. He wants to share it. Ultimately, nuclear is a small industry, right? There's 100 roughly nuclear plants in the U.S. and 450 roughly worldwide. So small industry, and the rising tide lifts all boats. So the good of the plant and the good of industry is really the good for the world.
Yeah, absolutely. Like, I love that he didn't just make this some proprietary thing that has a patent, no one's able to use or something. It's just in a new reg and just in this book. And yeah, it's something that like we try to do at nucleartalentboost.com too. We're just giving everyone free lessons because, if the world's really like on fire and there's all these wars breaking out because of energy scarcity or whatever, it just shouldn't be a secret how to have a safe, economical plant. And so just pooling people's collective knowledge together. And yeah, I mean, this book spent like $40 on it, used on Amazon or something. I mean, it saved the companies that I've worked for like $500,000 or more, and gotten like some thousands of dollars of spot bonuses based on it.
So really good ROI right there. Really good ROI.
Yeah, I think that just continuing on our show and tell book series. Have you got this one? It's the Instrument Engineer's Handbook by Liptak.
I don't think I have that one, though. As you can tell behind me in my messy office, I do like to read, but I don't think that one's on my shelf.
Yeah, look how thick this is, and it's not even the thickest one in the series.
Wild.
And people have referred to it as like the Bible of I&C engineering. I would believe it, actually. That's another like has saved my company $1 million or more type of books. And you can get it at isa.org, their library. It just shows you every single type of sensor in the world ever conceived, a dozen of the different leading manufacturers of each, rough accuracies of them and stuff. Yeah, just scrolling through that book and trying to find the right sensor for the right process line at the right accuracy that will also survive in radiation and stuff like that. It's been a great book. What's your favorite I&C book?
Ooh, I gotta say, maintenance of process instrumentation. I think that's written into my contract.
Well, yeah, you're paid to say that, and you're not wrong.
Yeah. Nuclear wide. Alvin Weinberg wrote the first nuclear era, and it's really good. It's not I&C related, but that's probably my go-to if somebody's like, I want to learn about the history of the nuclear industry, because he was a lab director at Oak Ridge and like was right in the mix of all of the initial reactor designs, and he has some actually really good perspective. I mean, that's my go-to if I need to recommend a good nuclear book.
Nice. So we were talking about how a rising tide raises all boats and stuff, and how you're not afraid to just put the book out there in the public for everyone to learn about. And I would think that part of that is because, AMS just has one of the best troubleshooting teams with like the most experience. Let's say it takes an hour to learn, but like a lifetime to master troubleshooting all these I&C systems. And like, yeah, I think it's totally fair to be superstitious about these systems because I'm pretty sure if I wear the wrong color of t-shirt, my I&C system ends up having hiccups. And everyone's got their own little superstitions about it. Yeah, and especially for EMC, the EPRI report that is like the EPRI standard troubleshooting guide that will point people to. You can tell like the author goes out of his way to say like, I have been humbled many times by ghosts in cables. And and so let's approach this systematically and in a spirit of humility, and we'll try to get through this. But yeah, I mean, you can have this $10 widget that's just keeping your plant down for years.
That's right. Yeah. And EMI issues are some of the worst because a lot of times they're intermittent or they're traced to some. It only happens when we turn this one pump on, or there's some variable frequency drive that when we actuate, or somebody's welding off somewhere during the outage and it's causing noise on our nuclear instrumentation, or it's just random electrical noise in the plant. And so troubleshooting an EMI issue just at a high level, there's three parts to any EMI issue, right? You got a victim circuit, something that's getting affected by the EMI. You've got an aggressor circuit like a VFD or pump or something out there that's generating a lot of noise, and you've got a coupling pad. That takes all three of those things to have an EMI issue. But finding which of those things that you can actually mitigate or to actually fix, that's a whole other story. And being able to do it in the plant while it's operating, or while they're in a last minute, we got to get this plant back online because we're having issues. That's a different,
while the VP's
story.
Yelling at you and
That's
you're
right.
Watching your bonus fly out the window.
That's right. And so that's where I think that's simple. There's three parts. Fix any one of the things, make the aggressor less noisy, eliminate the coupling path, or mitigate the victim and shield it, or do something, change the routing to where it can't be affected anymore. That's not that complicated, right? But having the right equipment and the right understanding to be able to characterize the noise and understand, okay, why won't a ferrite bead work in this instance? Because in some instances, you throw a ferrite on it, depending on how the noise is propagating, it might make it worse because it can actually reflect. And so understanding when to apply the different tools in your tool belt is half the battle. There's a lot of nuance to it. It's very, very rarely straightforward.
Yeah. If you look on my microphone, you can see like an FCC stamp and like a CE stamp. These things are just on so many of the things in our life. But at least until like a few years ago, I'd never stopped to wonder, what are these things and what do they mean? And what is this bulge at the end of this cable? What's it about?
Yeah, every laptop power cord likely has a ferrite. If you really look around, there's evidence of EMC all around. But even with like FCC, when you talk about the nuclear industry, the testing levels and the requirements for a CE stamp or for an FCC, it may or may not be enough to go into your nuclear plant. It likely isn't. Sometimes the CE declaration is just that. It's a declaration. It doesn't necessarily mean they've went to all the test levels or all of the things that they would need to do. So it can get very tricky when you get into the weeds and it's like, what does this actually mean? How much testing did this actually undergo?
Yeah. The manufacturer said they tested it and it's cool, so it must be cool. Why would you question that, Adam?
Because I've had to question it before.
I know.
You get to the end of that rainbow and you find out what's actually happened.
Yeah, the disappointing moment in any engineer's life when they go from doing stuff on paper to stuff in real life, realizing that your widget only does half the stuff that the spec sheet says that it would.
That's right.
But yeah, in half of the cases, this little bulge thing is probably a ferrite bead and it's got to do with EMC. So yeah, I think that we should talk a bit more about how can a non-I&C individual, either coming straight out of college or someone who's been in the nuclear industry for a while but has never officially been an I&C engineer, how do they transition? What would be your advice to them?
That's a great question, Russell. I think that one of the best things about the nuclear industry that is sometimes not always a good thing, but we document everything, and half of it's available on Atoms you can get. There's lots of existing documentation that you can find just from a quick Google search. And by and large, especially in the existing fleet, things haven't really changed all that much in the last 45 years. There's a lot of documentation that if you put in a little bit of time, you can learn a lot from things like the $40 Maintenance and Process Instrumentation and Control Systems book. That was one of the first things I did when I was at AMS. And in general, new regs are out there. There's so many standards and things that are out there that you can find them. It's not necessarily going to be, take this 4-day course and you learn everything you need to know about being a nuclear I&C engineer. There's other good resources out there, and obviously Russell, I think, is working to put together a great library of those types of items. There's a lot out there. If you're willing to put in the time and to read the 3,000 page ISA instrumentation guide, you can do it. In my own personal experience, most of the time things don't get handed to you. Most of the time you're going to have to put in the work. You're going to have to go out and in your off time, not on company time, you're going to have to go in and read and learn and expand your skill set, find a new industry or a new niche for yourself. EPRI has a lot of guides that you can go download for free. There's so much stuff in the nuclear, and that's pretty unique to the nuclear world. It's just because we've had to document so much, because we've had such a kind of unique history. That's not necessarily the case in a lot of these other industries. That's my number one. Just go read a bunch. It's sometimes a little laborious, but it's worth it if you're going to really want to advance.
Yeah, No, I agree. People can be very allergic to like doing work for free, but honestly, doing work for free just to get the experience
Right.
is, people will pay money to go to college, but you won't do something for free just to advance your knowledge. So,
That's the really like kind of unique thing about the just the world that we live in today. Basically, all of the information in human existence is available for free on the internet. I mean, there's obviously some that's not, but
mhm.
98% of everything that's ever been done and recorded is probably out there on the internet somewhere. It's just taking the time to find it. And I mean, YouTube videos to curate it. I mean, MIT has their open coursework.
Mhm.
If you have the time and energy and desire, you can learn about as much as you want. The only cap is yourself. It puts the onus on the individual. It's like how much effort and time and energy are you willing to put into this, and how much do you want to try to learn on the job. You can read about a nuclear plant for hours and hours and hours, but until you like actually go in and see it, and you're like, oh wow, there's a lot of pipes in here, and this is
See all
really
those
the
tangled up
scale of this.
sensing lines.
Go inside containment, like, oh, there's a reactor over there, like that kind of stuff.
Yeah.
This is what a steam generator looks like. That's hard to replicate.
Yeah, my recommendation to people would be to join ISA.org, the International Society of Automation. They've got like a student package if you're a student. It's like $15 for a membership. And even like the professional membership is like $140 a year. And that $140 gets you access to all of the different standards, not just the nuclear like ISA 67 set of standards. They'll teach you how to do set points and how to do like 10 other things. It also gets you the ISA 84 and all these other non-nuclear, I&C related standards, and just popping those open and having a recourse to them is a big benefit. ISA.org also has both paid and free general I&C classes and videos and tutorials, and a very powerful resource to people. One way to explain nuclear I&C and like how to become a nuclear I&C engineer that I've found very useful was one that Greg Clarkson told me, the Rock Creek Innovations, now Paragon safety related control system inventor, amongst other things that he and his really great outfit have done. But anyway, he told me once, at the end of the day, like you have to have both the nuts and bolts, hands-on experience, and you also have to have like the regulatory top level book smarts, plant design aspect that makes a complete nuclear I&C engineer when you have both of those. He started out at it just touching FPGA modules for like Motorola and other like hands-on technician-y stuff, and then just grew in his knowledge, got to that middle place. Whereas I like started from, I just learned the licensing stuff. I was a licensing engineer, and the guy who was in charge of chapter 7, the I&C chapter for NewScale, he had some family issues come up and was just out of work for a few months, and it's like hot potatoes, who's going to take chapter 7? And I was just like, man, I'll take it. I want to learn about I&C. And so I did. And then I went to a different place and was in procurement, and they were just like, who's going to procure all the I&C stuff? And I was just like, man, I'll do it. I love I&C stuff. And then much later on, I literally labeled an I&C engineer person, coming at it from that way down. And then like I actually started touching wires and stuff and flukes in a CGD lab. But you have to start somewhere. Start here or start there. But like you got to get to this middle place where you've got both skill sets if you want to be like a true I&C engineer as opposed to like an I&C technician. And yeah, there's just lots of roads to get there. And it's such an in-demand field. People are very willing to take like a journeyman I&C engineer because you can't go become an I&C engineer at a college.
That's right.
And that recruiting line just isn't there. And I'm trying to help build it for the industry, not only in nuclear, but like every industry is just struggling to find I&C people. And so if you're feeling in a rut, definitely consider strongly becoming an I&C engineer. There's not that much math. There's math, but it's not like too bad. And
that's right. 90% of what we do it's not that complicated. It's complicated, don't get me wrong, especially when you're just talking about a 420 milliamp loop.
It's like some basic algebra.
That's right. It can be done. It can be done.
How did you get into I&C, right? What was your journey?
So I kind of tripped into it. My background in studying manufacturing was kind of what I studied coming out of school. And as I was walking at a career fair in my college and looking around at different companies, not really having a great clarity on what I wanted to do with my life, other than I knew I wanted to be a little bit more on the business side. And so I was kind of just talking to companies like, this is kind of what I'm looking for. And do you have a role like that? Because it's not really how a lot of positions are posted, or else it's like a very direct direct sales, like you're just selling kind of widgets kind of thing. And that really wasn't what I wanted to do in my life. And so I stopped in front of this booth that had a picture of a big cooling tower on it. I'm like, that's kind of interesting. And the HR lady started talking to me, and I was like, well, this is kind of what I want to do, kind of be at the interface between business and the technical. And she was like, we're actually looking for somebody like that. And I was like, oh, really? And of course, with AMS, interviewed with them and found really the perfect meld of what they were looking for and what I was wanting to do. And it's been a really great fit for me. It's very rare that your first job out of college is the one you're like, this is great. We travel a decent amount of work for AMS, going to all of the different nuclear plants around the country. And so I've got a bunch of just random stuff saved on my iPad from the NRC's I&C guide and those types of things that you can learn on, or when you only watch so much Netflix on.
Totally normal things.
Yeah, that's right. That's kind of how I got into it, and then getting to know a lot of people around the industry. I've been very active in the American Nuclear Society, and they have a human factors and instrumentation and controls division that I've been pretty active and engaged with, and that's just kind of continued to just keep the flywheel going of the interest and the engagement.
Oh yeah, I think that the great thing about I&C is that there's so many different facets to it. There's so many different sensors to go ground up, become an expert in. It's definitely always interesting. There's still so much innovation left to do, right? Blue Wave and other companies using AI to like squeeze out extra megawatts from plants. There's just all these different things where a smart entrepreneurial engineer can like get the widget or get the process to increase plant efficiency by like 0.001%. And like that doesn't sound like a lot, but that's millions of dollars more
talking
power
megawatt
every year.
hours. When you're running a plant 365 days a year and electricity prices are $40 megawatt, whatever it is right now, it adds up pretty quick.
So that's where, the entrepreneurial spirit is like most alive in I&C land. And that's what I love about it. You can actually feasibly start an I&C company and like get a patent and like sell a product versus like making a novel new reactor and like you go fundraise $1 billion and it's still not enough.
That's a whole other
yeah.
And that's the exciting piece to me. As all of these new reactor designs come online, there are going to be new problems that aren't going to be what the existing supplier base is really geared up to solve. And so that does create a lot of opportunity, I think, to go solve those problems. Rising tide lifts all boats. There's going to be plenty of work for everybody when we start building these things. Most of them, we're not talking about building 50. If you look at all the climate goals, you look at all of the electricity demand with data center, I mean, we need more nuclear plants, whether it's gigawatt scale, AP1000s. We're going to need advanced reactors. I need microreactor. There's plenty to go around. It's just we got to push them over the edge.
Yeah, exactly. All these first of a kind instruments and really weird process fluids that need to be like ridiculously accurate for some random reason, and all these sorts of really neat things. It's really funny that I think that mentorship is like such a big thing. You can go read all these books, but compared to actually touching a widget and compared to having like that wise old sage looking over your shoulder, it's something that I've been blessed with to have so many mentors in I&C and other areas of the nuclear life cycle. What I'm trying to do with nucleartalentboost.com is to give this virtual mentorship experience that's at least better than nothing, maybe even pretty good. Nothing replaces the wise old sage physically touching you, but I'm just laughing so much to just hear that, like, I mean, you've got like a very enviable position. Like there's so many hopeful and like aspiring I&C engineers who've been reading these books for years and years, but like never had that wise old sage. And yeah, I mean, you just like walked up to a career path, walked up at a career fair and just ended up having Dr. Hashemian himself, who's like a past ANS president. And like before that was just like a self-made, super successful I&C person. And it's just funny that you've just been spoiled by such a good mentor purely out of providence.
I count my blessings every day. Very thankful to have Dr. Hashemian. He has been a very good mentor to me. And that's something, mentoring, and like it's something that he says a lot. He never really had like especially on the business side of things and how to run a company. It's like he was kind of learning as he went, and obviously has done very well for himself. But also like he looks at it as like there's some things that he's like, if somebody had told me that, I would have spent 5 less years trying to go after this one area. Or in any thing where you've been very successful, it's easy to look back and be like, man, if I could have tweaked 2 or 3 or 4 little things here and there, and And that's something that I want to make sure I tweak all the right things. Like I want to learn from many people as I can. Good advice and maybe some bad advice here and there, and hopefully be discerning. Try to get as much information as I can. Finding somebody that does care about you, and having some discernment and knowing what to listen to. And if you have a conviction, the best way to do something is when you're convicted about it, whether it's the right way or the wrong way. Just go at it 100%. Hush is 100% in everything. So I think that's a good takeaway for the young aspiring I&C engineer out there. Jump in the deep end, go both feet forward and see what happens.
Or like, the 55-year-old mechanical engineer that's just burnt out. It's always so much better in life to like, you've got a good thing going, but you want a great thing to be going. When you make the moves in your career, when you're in that space, as opposed to like when you're burnt out and just like hate your job, you're going to find a lot more fruit. Take that for what it's worth. That's how I've done most of my career moves, is that like, I've been like really happy doing what I'm doing, but like, I just see this opportunity to do something even better. And like, I go do it. I'll like reach out to people and I'll be like, hey, like I know this company that like could really use you right now as like a recruiter, right? And they'll just be like, no, I'm happy where I am. And I'm just like, well, I mean, you're telling me if I told you that like I could give you like a director level job with 40% more money, remote work, you just aren't interested in that at all. But people are who they are, but everyone chooses their own path.
And sometimes, I mean, the grass isn't always greener. Sometimes it's really when you find a good thing, go deep. That would be my other good advice. Jumping around to a different company every 2 or 3 years. Also,
that's like a red flag.
That's right. You don't want to be a mile wide and an inch deep. Finding something good and sticking with it, but you should find something good. That's the step one.
Yeah, like I've taken pay cuts in my career because a project was just so phenomenal sounding, and the mentor there was just so good. And so like definitely take a total value proposition. Yeah, and so you were joking earlier about how like, oh, you just take this 4-day class and you're an I&C expert now. But like, AMS does offer a 5-day I&C class, and like you really do pop out an expert, and that's something that I would plug.
Yeah, we do. We just actually finished one up here this last August. We touch on basically everything we know as a company, and from process instrumentation, talking about calibration and response time testing of different sensors, to how rod control systems work, to EMC related issues, cable testing, a lot of laboratory demonstrations as well. So we have a couple trainings coming up in February, one on cable testing, condition monitoring, troubleshooting, and then another on EMC. That'll be in Orlando in February. I think the dates should be on our website. We're working to finalize those.
And that cable aging stuff's like super important for like those 80-year-old reactors that are trying to go to 100 years, right?
That's right. So the two biggest pushes for AMS in the existing fleet right now are the online calibration monitoring I mentioned, and then cable aging management. So you have these cables that most of them are in the 40 to 60 year period of operation. And now many of them are going through subsequent license renewal applications, and most of them will start, I think the earliest start in like 2028, 2029, start entering into that 60 to 80 year period. And I think a lot of them will eventually go to 100 as long as they keep working and we keep doing what we need to. I mean, they're a great asset that works really well, and for the most part, or especially after some of the recent legislation, economical. It's a lot easier to keep something going than to build something new. I think that the world is starting to realize that. I mean, the mind-blowing reality that 20% of the entire electricity for the country comes from 95 nuclear power plants. Absolutely wild. They're not just going to turn those off. I mean, you're already seeing, they just announced that TMI 1 is coming, their constellation is going to turn that back on, and they're working on Palisades. And so I think that the world is starting to realize that just the incredible value that these plants have.
And they're all getting digital I&C upgrades. All the more reason to become an I&C
That's
engineer.
right. There is a lot of, I mean, you've seen with the Limerick project, and there's challenges associated with that, and new opportunities. And most of the plants that are going to go to 80 years or at some point probably going to get digital instrumentation control systems, I think. And my big takeaway recently has been like the old saying that the best time to plant a tree was like 30 years ago, and the second best time is today. The best time to build a nuclear plant was 45 years ago, but the second best time is today. So I think we're in a good time for that.
Speaking to a couple of the more of the things that you do rod control system testing, you do custom build sensors for advanced reactor plants. You've got some DOE grants to do those sorts of R&D stuff. You do materials testing.
We do, yeah. So I'll touch on a couple. You talk about rod control system testing. That's a fun one. So historically, plants have had a commitment that they basically, before they come up out of the outage, they need to verify that their rod control systems are operating properly, like control rod drive mechanisms that actually move the rods rods in and out of the reactor or sequencing properly, and then the rods actually drop from a certain amount of time. Expect type measurements that have to be done. And so that's an area that, again, you talked about AI earlier, is when you actually move a control rod from 0 to 228 steps, and you have 52 control rods, and each one of those steps generates an electrical trace that for a lift, movable, and stationary gripper. That's a ton of data. And we're to a point in the world where we can take that data, and we have that data from the last basically 30 years where we've been doing this testing in plants. And so now we're developing machine learning algorithms and AI tools to be able to do things that a manual person that's reviewing the data in a plant at 3 a.m. can find, but it's automated, or it requires a lot of manual labor. And so integrating those types of things into our software, so it's automatically done or automatically flagged. Those are the kind of the newer areas that for the existing fleet and the next generation of reactors, those kind of advanced tools that you can integrate to do something that you've been doing for a long time, but do it better and do it more effectively. And there's a lot that in the rod control world, especially the existing fleet, you have aging systems, and you have rod control systems that have been installed for a long time. More issues with degradation or crud buildup. That's a fun one. The materials testing is another one. We really got into that with a lot of the aging management work we've done on cables. And that's another one of the things that I'm very thankful for about AMS and how we operate as a company. We are a small business. We have a big footprint, but really at our core, we still have a very entrepreneurial spirit. And if we see a need, Dr. Hashemian is very good about all right, go try it. And sometimes it sticks, sometimes it doesn't. That's how the materials testing laboratory came in about. We had an engineer that was really good at materials, and he was like, I think I can really expand this and we can really grow. And Haas was like, sure, we can buy this very expensive materials testing equipment. And he had faith in him, and it turned into a whole little business unit of AMS. It takes an enterprising engineer to be like, hey, I'm going to go ask for this really expensive piece of microscope or whatever, the thermogravimetric analysis equipment that I'm going to use. Finding the right mentor that believes in you. That's a really cool kind of tying it back into the career development aspect. Having the courage to make that request and courage in your own abilities, it turns into a really cool thing when it works out.
Yeah. No, we could be here all day, and we gotta be cutting the show here soon. But I'll just quick say, you do motor and generator diagnostics. Yeah, Andy Knack on episode 1 of the Nuclear Talent Show, we were talking about the physical testing of software quality, but you just inject 1,000 signals and make sure that the control system does 1,000 things you expected it to and stuff.
Quantifying the reliability of software for digital I&C systems.
Yeah, but you guys are into that. You've got your own little setup, and there's a million things that are on your website, and probably another dozen that you don't even post on your website. And I just encourage people to go to AMS-corp.com. There is an AMS Nuclear that is some different company, but the Analysis and Measurement Services Corporation, AMS-corp.com is where people should go to learn more about you guys. And
that's right. Yeah, and I can give you my email too, Russell, and you can put in the show notes or whatnot. And
shoot it out.
Happy to hear from people, and if you have questions, love to talk more.
Yeah, Adam@AMScorp.com, right?
That's right. Adam@AMS-corp.com.
Awesome. Thanks so much for your time today. Really looking forward to partnering with you guys and other people to help solve all the I&C problems in the world and all the other problems in the world, making this great noble industry continue forward. So
that's right. No, I think
you keep up the good work.
Likewise, Russell, best of luck to you. I do think that low-cost electricity is the best way to get people out of poverty around the world, and you can pretty closely track human flourishing and electricity demand.
Yeah.
And so I think we're doing really good work and support stuff. So thank you for all you're doing, and best of luck.
Thanks, Adam.
We hope you enjoyed the show. We're helping solve the energy crisis for our children and the world by addressing the nuclear talent shortage. Please help us by liking, sharing, and subscribing, registering on nucleartalentboost.com, and telling your human resources and procurement departments you'd like to work with nucleartalentscout.com for all your staffing needs.